In the last video, we conducted the numerical analysis of the national income with lag dependence. Now we are going to introduce the induced investment part in it. So let us see how we can do this. Induced investment is the addition in this video. So induced investment alongside with the autonomous investment is what we will see here. Consumption function will remain as it was before. Its numerical value might change, but the process is the same, that last time period's income is determining the current time period's consumption. Whereas the investment function now has two components instead of one. Previously it had one part, that is the autonomous investment, but now it has induced part as well. And it says that the 20% of the last year's income is what we are investing. So this is the overall investment function that has autonomous part as well as the induced part. And the initial condition of national income is also given. So MPC is equal to 0.4 is something that we have extracted from the given information, and that is between 0 and 1. This is something we will be using in our decision. And now CT and IET, both of the values, they have been substituted. We know that C naught and MPC. Then we can rearrange it. When we rearrange it, we get this form, and this is the constant side on the right hand side. Now this is equal to 0.6 YT minus 1, and this is YT. This is 300, and now we can extract the value of A, and we can also extract the value of C here. Depending upon the value of A, we usually choose the formula, and here it is equal to minus 0.6, which is definitely not equal to minus 1. This implies that we can use the first of the formulas for the first order difference equation. This is the testimony of that, and this is the formula where C is equal to 300, Y naught is represented like this, B is equal to minus A, and A is equal to minus 6. So these simple steps are self-explanatory, and we have substituted all the values that we had, and this is the time path that we have developed. This is the complementary part, this is the equilibrium value, that is 750. This was the equation that we solved. We can write it with leads as well if we want to. And now this is that expression that will determine the dynamic stability. Its actual value will help us to know if we have a non-oscillatory or oscillatory time path. So it is non-negative, therefore it is non-oscillatory, and its absolute value will help us to determine if we have a conversion case, which in this case is less than 1, which means that we have a convergent case or convergent time path. So this is what we have. In other words, we can write it like this. This guides us about the selection criterion that we have made, and it shows that we have a time path for national income this time which is convergent and which is non-oscillatory in pattern. Moreover, we can write it in an elaborated way. As you can see, the deviation part, and then why it converges to 0 when we allow the time to pass indefinitely. It's because of this exponential part, which has an absolute value of b less than 1, which means that there will be convergence because this part will fade away. This coefficient will also be a victim of its process of fading away. This will be the particular integral, and finally the time path will converge to equilibrium value, that is 750, as the time passes indefinitely. And this is how we can represent the whole situation, where time is represented on the x-axis, yt on the y-axis. You can see the deviation is happening in a way which is declining. As you can see, the deviation is decreasing, and it's a stepped graph because it is a difference equation situation. The convergence is there, and above the equilibrium it happens, below the equilibrium it doesn't. So it means that there are no oscillations and it is a non-oscillatory case. So all of these things that we have studied are getting verified here in this diagram as well, where we can see that there is non-oscillatory time path and we have convergent phenomenon, due to which we have dynamic stability. This was the solution. This is how we developed the equation, and then this was the given information. Induced investment was the new thing in it. Otherwise, other things were as they were previously. So this is how we can introduce the induced investment part in the investment function, and still we are able to analyze the national income dynamics, and that this is possible using the difference equations. Thank you.